So ionic compounds, as we just were talking about, there's a cation and an anion. The cation is a positive charge and the anion is a negative charge. There has to be a positive and a negative for them to be attracted to each other. Like charges repel, opposite charges attract. So in the ionic compound, there will be two ions, one positive, one negative. The positive ion is always listed first, both in the name and in the formula. Why? Convention. Okay? When you address a formal invitation to someone, it's always Mr. and Mrs., right? It's not Mrs. and Mr. Why? Because that's how we've always done it. It's conventional. Okay? So we have decided we're going to list the positive ion first and then the negative. So that there's no big reason behind it. So we've learned how to write names and formulas for these different ions. So if we had something like lead-2 ion, what is the formula for that ion? We need the symbol for lead, with Pb, and what does the Roman numeral 2 tell us? The charge. 2 plus. Metals form positive ions, nonmetals form negative ions. So if we had Pb 2 plus, and then maybe we have an anion like oxide ion. Oxide ion is the ion of what element? Oxygen. So the symbol is O, and then the charge we find from the periodic table. So we find oxygen, it's in group 6A. So you can say, well, group number -8 gives us a -2 charge. Or you can start with the noble gases. They don't make ions, they have a charge of 0. Count backwards. -1 for column 7A, -2 for column 6A. So oxide ion has a 2 minus charge. Remember that we put the sign after the number, and we always include the sign, even if it's positive, which is different than math. So in order to form a compound between these two ions, we have to figure out how many of each of them we need so that when they all get together, the overall charge is 0. Because in a compound, the overall charge is 0. So if I put one lead-2 ion and one oxide ion together and added their charges, what would the overall charge be? It would be 0. And so we can write a formula for compound here, and it's going to be PbO. When I write the formula for the compound, I do not write the charges of the ions. I only write the letters, the symbol of the elements. Okay? We can get the charge for the oxide ion from the periodic table. From this ratio, I'll show you how we can figure out the charge on the lead ion. So that's the formula for the compound that forms between lead-2 ion and oxide ion. If we are given a formula like this and asked to write the name, we just name the cation first, and then we name the anion. The name of this one was lead-2 ion. So we write lead-2. There's no space between lead and the parentheses. That's part of his name. And then oxide. And so we leave a space because there's two names. Lead-2 oxide is the name for that compound. Yes?
So if we just saw the PbO, and we should know that the oxide is -2 for the charge, then because there's no coefficients, we should just know that
it's 1 to 1. Remember, chemists do not like to write the number 1. And so PbO means that there's one Pb and one O.
Right. Well,
and so you know that from the periodic table that the oxygen's 2 minus. From the periodic table, you can't figure out what the charge on the lead is, right?
But in case of the equation, we should be able to figure out that.
Right. So we know that there's a total -2 charge, and we know that they have to add up to 0, and so we know there must be a total +2 charge, and so then we could figure out that that's a +2. And we'll do some more examples of that. Let's look at, what if we had lithium ion and sulfide ion. What's the formula for lithium ion? Li, and what charge does it have? It's got a +1 charge because it's in group 1A. Group 1A, +1. Group 2A, +2. Group 3A, +3. And then there were those 3 pesky ones, zinc, silver, and cadmium, that you have to memorize. So lithium plus. Notice I write the symbol plus or minus. I didn't write the number 1. We don't write ones unless we have to. Sulfide comes from sulfur, and what's the charge on a sulfide ion? 2 negative. So if we're trying to put these 2 together, we need to figure out, well, how many of each of them do I need so when I add them up, they come out to 0. If I just have 1 lithium and 1 sulfide, the charges will add up to -1, right? It's not going to be 0. So I would need 2 of these lithium ions to balance the charge on the sulfide. You see that? Yeah, and so then the formula for the compound will be Li2S. There are different ways to approach figuring out how many of each you need. Least common multiple is what we're looking for if you're a math person. Okay, what's the smallest number that has both of these as a factor? Well, it's 2. And so I have to multiply this one by 2, and I have to multiply that one by 1, and I come up with this. So students who get that, they're fine. So I'm not going to talk to those people anymore. The other way to do it is how I did it here. I just drew another one until I could see that these charges would cancel out those charges. If I have -2, I need to have +2. I can't change the charge on the ion. I can only add some more of them if I need to. So that's another way. The other way, which a lot of students like, is often called a crisscross method. So you write the 2 different ions with their charges. First, look at the charges and ask yourself, are they the same but opposite in sign? Well, no, they're not. This is +1, that one's -2. So then we could do crisscross. And the crisscross idea is you take the sign of one becomes the subscript of the other, not the sign, the charge, and the charge of this one becomes the subscript on that one. So we've got a 2 here, and we have an unwritten 1 over there. So this is lithium 2S. I didn't write the 1 up here. I don't write the 1 down here either. But the 2 comes here. And so the charges have done a crisscross thing. That'll work about 95% of the time. Occasionally that'll screw you over. The thing is, these subscripts need to be in the lowest ratio. If we had 4 lithiums and 2 sulfurs, their charges would add up to 0, but it's not the lowest ratio, and so that would not be considered correct. That's a kind of a smallish point that we'll go over more in lecture. Any questions before I go to another slide and make more room here? So let's do another one. Let's do, where am I? Let's start in the right part of the page. Let's do Fe 3+ and oxygen. What's the formula for the compound formed between those two ions? Well, the charges are not the same, right? One's 3 and one's 2. So we can't just shove them together. We could do the crisscross thing. So if we crisscross them, what do we get? Oops. So this is going to be a 2, and this is going to be a 3. Here's Fe and O. We're going to get Fe2O3. And that's correct. Let's do more of a thinking about it, drawing pictures way. So here I've got O2 minus, I have Fe3 plus. And what I'm going to do down here is I'm just going to keep a tally of my total negative and positive charges. And I'm going to add ions as needed until I get these to be equal. So here I've got positive 3 and negative 2. I need more negative charges. I can't change the charge on the oxide ion, but I could add another one. So I could draw another one in here. Now what's my total negative charge? 4 negative. I've got 2 minus and 2 minus. That gives me a total of 4 minus. Now I've got too many negative charges and not enough positive charges. So that means I need to draw another positive ion. And what's the total positive charge from those 2 iron ions? 6 plus. Then you're thinking, dang, we're just going back and forth and back and forth. It's like my grandma eating bread and jam. She'd take a little bread and some jam at the beginning of the meal, and then she'd eat the bread and she had jam left, so she needed another roll, right? And she's putting jam on the roll, and then there's not enough jam, so she needs more jam. She could go on all night. She called it bread and with it. Back and forth, back and forth. Well, we'll just keep plugging away. We need more negative charges. So add another one of these guys. Now what's our total negative charge? 2, 4, 6. 6 minus. Ding, 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 ding. There we go. We've got plus 6 and minus 6. When we put those together, they add up to 0. You see how that works? Yeah. If you see how it works, it's not hard. These are small whole numbers we're dealing with. Okay? So then I look at the picture I've drawn, and I have 2 irons, so Fe2, and I have 3 oxygens, O3. Okay, so that is the formula for that compound. When we're naming the compound, we give the name of the first ion and the name of the second ion. And we already know the charges because we started with the charges. What's the name of Fe3 plus? Iron, Roman numerals 3. Iron needs Roman numerals because it's not in group 1A, 2A, 3A, zinc, silver, or cadmium. So remember, groups 1A, 2A, 3A, plus zinc, silver, and cadmium, no Roman numeral. All of the other metals, you have to give it a Roman numeral. Iron forms 2 different ions, plus 2 and plus 3. And there's nowhere we can tell from the periodic table. So if we're writing the name of this compound with oxygen and we don't tell the charge, the person reading the name will not know which compound we're talking about because there's 2 different compounds between iron and oxygen. So this is the name for this iron 3 plus ion. And the name of this one is what? Oxide. So for these monoatomic anions, There's just one kind of element there. You take the element name, oxygen, and you change the ending to "ide." Oxygen becomes oxide, and that's the name for the compound. Any questions? No, that's not what I want. There's a formula. Let's write the name. We need to look at what are the two ions. Well, the first element is tin. Do we know the charge on tin from the periodic table? Group 1A, 2A, 3A, zinc, silver, cadmium. Is it one of those? No, it isn't. Okay, so we don't know what the charge is. So let's go on to the other one. Chloride. What's the charge on the chloride ion? -1. We can use the charge on the chloride plus the number of them and the number of tins to figure out what the charge is on the tin ion. So I'm going to go with the picture method. So I've got 4 of these guys, right? SnCl4, the 4 tells me I have 4 chlorides. Sn with no number tells me I only have 1 of those. So what's the total charge on those 4 chloride ions? -4. Okay, if this is a compound, then the total positive charge must be 4 plus, right? Because the positive and negative charges have to add up to 0. There's only 1 of these. I'm not dividing this among 2 or 3 or 4 other ions. There's only 1. It must have a +4 charge. So that must be 4 plus. We just figure it out. Now that we know the charge on this, we can write the name. So Sn is tin. And then what's the Roman numeral for 4? IV. What's 1 before 5? And then this is chloride. Tin 4 chloride. Any questions? So that's a brief summary of how to name binary ionic compounds.